Simplifying variable root. Square root of x squared. In this case, square root of x squared equal and opposites. They cancel each other out, giving you x. But do remember the absolute value sign. So we need an absolute value sign. The cube root of x to the third, let's realize that they cancel each other out once again because it's the cube root of a cube, or number to the third. So that leaves us with just an x. In this case, we do not need absolute value signs because it's an odd number root. So it's only needed for even number roots. And the last question we have, what if we have square root of x minus 2? What can x be? And can use inequalities to represent possible answers. So let's go with an example real quick. But for reference, we have the square root of x squared. Keep in mind, square root of x squared, the square root and the square cancel each other out, giving us just x. The one thing we do want to remember, because they are equal and opposite, and then you're taking the square first, your value is always going to be positive. So that's our absolute value sign. As an example, if we have the square root of 5 squared, if I square the 5 times 5 is 25. Then I take the square root of 25. In this case, I get positive 5. Hey. Okay. Let's try this again, but with the negative. Negative 5 squared. Negative 5 times negative 5. Positive 25, right? Negative times negative is a positive. So positive 25. The square root of 25, I would get 5. So notice our x value is always turning out to be a positive, and it'll give you a positive result in the end in this case. So on the other hand, a cube root, for instance, cube root of 3 to the third. It's like saying 3 times 3 times 3, right? 3 times 3 is 9. 9 times 3, 27. So the cube root of 27 then. Well, one number times itself 3 times will give you 27. 3, we just checked that, right? We had 3 3s. 3 times 3 times 3 will give us 27. How about the negative side? Negative 3 to the third, then cube root. So we would have a negative 3 times negative 3 times negative 3, and then we would have a negative 3 times negative 3 gives us positive 9. Positive 9 times negative 3 gives us negative 27. I'm missing a cube root on that. Otherwise, it's the square root, right? So be aware of that. I need a cube root. I'll come back and fix it in a minute. So now the cube root of negative 27, okay, gives us negative 3. Gives you the exact answer that you need. So how about if we have the square root of x minus 2 then? What could x be? Well, one way to look at this, where is our limit? Do we have a limit? And there is a limit. If we go x minus 2 and set it equal to 0, there's a limit. Because we want to find out when do we get a negative value for a radicand. If you ever try taking the square root of a negative number, it doesn't work. You get another result. Agreed? So in that case, let's solve for x. So plus 2x from both sides. Cancel each other out, leaving us with x equals 2. So x equals 2 is our boundary. It's our critical value that defines the border between positive and negative values. So therefore, x is greater than or equal to 2. Well, how's that possible, you probably say, right? Let's try 3 examples in this case. That way you can visually see a little bit better. So, 3 examples. And one of them, let's go with the first one. It's going to be a number lower than the 2 value that we just found, the critical value. The second one, we're going to have a number equal to the critical value, in other words, 2, so the x equals 2. And the last one is a number higher than the critical value, in other words, 3. And let's see what we get for results. If we try the lower case scenario, where we have a 1 for x, well, 1 minus 2 gives us negative 1, right? Now try taking the square root of negative 1 on your calculator. Your calculator is going to give you an error. So if I take second and then push the x squared button, gives me the square root, and I push the negative sign at the very bottom of our calculator, close my parentheses after pushing the 1 and hit enter. It gives me now a result. It doesn't work. Okay. Since that doesn't work, we can say non-real result. That's our answer, technically. How about the square root of 2 minus 2? Well, that just gives us 0. 2 minus 2 is 0. The square root of 0, well, that's 0. Try it on your calculator. I recommend it. So, 0 is our answer. And 3 minus 2, for the next case scenario, 3 minus 2 will give us positive 1. Square root of 1, 1 number times itself gives you 1. 1. 1 times 1, right? So 1 is our answer. If you notice, the more negative your answer becomes before you take the square root, then you won't be able to do it anymore. So in other words, if you make it a 0, you're going to end up with negative 2. Make it a negative 1, you're going to end up with negative 3, etc. So if you go down to the lower values, the negative values, it won't work. You're getting a non-real result. Go to the higher values, in this case 2, 3, 4, 5, 6, etc. for x, you're going to get a positive value, which now you can take the square root of it. So there it is. That's the reason why in this case it works. Well, finally let's remember that I had to fix one of those, right? So let's remember that I was missing a negative 3 there. Or pardon me, exponent of 3, or exponential root of 3. So there we go. There's a root of 3 before I technically forget in our notes. So now our problems are completed.